Hi guys, Professor Latimer here, the CC Mom Who Loves Science, and today we're going to talk about CC Cycle 3, Week 20, Hands-on Science Experiment. We're talking about candy probability, and this will be on page 266 and 267 in your Foundations Guide, and that's what we'll be looking at today. So we're continuing our exploration of probability. And probability is the mathematical study of chance. You can find a little bit more about that on page 263. So basically, it's how likely is something to happen. And so it recommends starting with a discussion of, okay, if I have candy and I have two different colors, say I'm going to use my gumball machine. So say I have 3 blue candies in my gumball machine and 1 orange. What is the probability that I will get the orange one? And so we learned about that for last week. So we're going to make a fraction. So the total number of outcomes or possibilities goes on the bottom. So we have 4 total candies that I could pick out of the gumball machine. And now, what is the probability that I will pick an orange one? Well, there's only one orange one, one possible outcome, desired outcome out of 4 total. Now, if I wanted a blue one, well, that would change our fraction. There's 3 desired outcomes out of 4 total. Now, ask them, okay, what if I want to make it more of an even chance? What would that look like? I could have 2 blue and 2 orange in my gumball machine, and that would make it a 2 out of 4 chance of getting an orange and a 2 out of 4 chance of getting a blue. So that's kind of a review of calculating probability. Last time we talked about flipping a coin and the 1 out of 2 possible chances of getting heads, for example. So today we're going to talk about what do you do when you have a larger group of items and a few more choices besides just 2. And we're going to talk about taking a sampling. So why would we need to take a sample of something? So think about if a scientist wanted to study something about all humans, could they ask every single human about that problem? No, they wouldn't be able to talk to everyone. Or think about a doctor. A doctor can't study every single cell in your body, but they could take a small sample, say take a small blood sample, and from that sample get a picture of what the rest of your body's health is like. And so we're going to study that a little bit too, about taking a sampling and if that is accurate in estimating what the actual probability would be. And so you can use candies, you could use poker chips. So I have a bag of poker chips, and I have red, white, and blue. Red, white, and blue in my bag. I have 100 total chips. And make sure it's a bag that you can't see through. And so what we're going to do is we're going to take a sample of our chips and see if we can use that sampling to estimate how many total of each color are in the bag. And so we're going to have the students take a sampling of 25 of these chips. And so the Foundations Guide has this table, recommends you have a table to keep track of each draw. So you're going to take one out, you're not going to put it back in the bag. So it says for draw number 1, say they got a white, and then they have these fractions here. To me, it was a little confusing to try to explain, maybe especially to younger ones, but basically it's trying to say, okay, I have picked one chip out of the bag and it was white. So there was a 1 out of 1 probability that that one was a white. And for red and blue, it was a zero outcome that I got a red or a blue on this first try. Now on the second draw, they got a blue. So they're updating this second number, this bottom number of the fraction each time. So this third draw, the bottom number is a 3. And basically you're just keeping track of how many times did you see each color. So by this third draw, we have seen the white 2 times. We've seen the red 0 times. We've seen the blue 1 time. That is one way to do it. The way I'm going to show today, just another option is just creating a fraction at the end. And so I'm just going to draw 25 real quick and we'll see if that works. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. All right, so I picked 25 poker chips out of my bag, and I'm going to see how many of each color I got, and then we're going to make a fraction. So make sure before you start this experiment, if you use whatever you use, that you make sure you know what your total amount of each color is. All right, so I got 2 reds. So I'm gonna write my fraction as I saw 2 reds out of 25 possible outcomes. I'll put an R there. Now for the blues, I'll make another fraction. I got 1, 2, 3, 4, 5, 6, 7. So I saw blue 7 times out of 25 choices. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 whites. 16 out of 25 whites. Okay, and so an easy way to figure out, to estimate what the actual distribution is I'm just going to multiply them by 4. Each one by 4. That way we're going to get our bottom number to be 100. So, and that's just going to give us an estimate of what our answer will be. So our bottom number is going to be 100 because 25 times 4 is 100. 16 times 4 is 64. And then we have 25 times 4 is 100. We have 7 times 4, which is 28. And then for our reds, we're going to have 25 times 4 is 100. And 2 times 4 is 8. So based off of our sampling, we took a sampling of 25 and we just used that to make an estimate. We estimated that there's probably 64 whites, 28 blues, and 8 reds. And the actual number is, I had 50 whites, 35 blues, and 15 reds. That's what I actually put into the bag. So you can see we got in the ballpark. And so that when nothing was totally off. And if you took you could try it again and take 25 more, increase your sampling size and see if you could get a closer number to your actual amounts. But that's what we are studying today, is sampling and seeing if you could take a small group from a larger group and study that small group and see if you can get similar results to the larger group. So I hope that makes sense, and have fun with this one, and I'll see you all soon.